Alright, this section of the video is verified by multiplying. So verifying by multiplying, what it means is that we're going to multiply by a term where we don't have a fraction anymore. So in our first example, tangent x over secant of x minus 1 is equal to cosecant of x plus cotangent of x. So we're going to focus on the left side because it's a fraction. Now, just like in 5.1, since we have a fraction, and if we look at the bottom, secant of x minus 1, if we were to eliminate fraction where we don't have it anymore, then we can simply multiply by the conjugate of it. So what I'm going to do is multiply top and bottom by secant of x plus 1 to the top and bottom. So when we multiply, on the top, it will be tangent of x, secant of x, plus, again, so I'm multiplying to everything. So this would be plus tangent of x times 1, tangent of x. Over the whole thing. Now, secant of x minus 1 times secant of x plus 1, you have to FOIL. And when you FOIL, you have secant square x minus 1. Now, I would suggest that you write it out to make sure to get it properly when you're FOILing. So again, when you multiply, FOIL it out so that make sure you get correct term. Alright, next, we can apply the Pythagorean identity here. Secant square x minus 1. Well, if we refer back to the Pythagorean identity, the Pythagorean identity was tangent square x plus 1 equal secant square x. Now, if I try to get the 1 with the secant square x, I'm going to subtract 1. Where we have tangent square x equal secant square x minus 1, which is the same as this one up here. So, as I rewrite the work, instead of secant square x minus 1, it will be tangent square x on the bottom. So, as I'm going to rewrite it right here, tangent of x times secant of x plus tangent of x all over. Now again, instead of secant square x minus 1, it will be tangent square x in the denominator. Now, I notice I have tangent x on the top and I have tangent square x on the bottom. So what I'm going to do is I'm going to rewrite the bottom. So the top will stay the same, the numerator will stay the same. Tangent of x, secant of x, plus tangent of x over. So instead of tangent square x, I will write it twice, multiplying each other. So tangent of x times tangent of x. So what's going to happen, since I actually have a tangent of x here, tangent of x right here, both in the numerator, and tangent of x in the denominator. So I'm actually going to divide tangent of x from here, from here, from here. So when I divide tangent x, secant of x divided by tangent of x will be secant x. Tangent of x divided by tangent of x will be just simply plus 1. And then tangent x divided by tangent x will be tangent x. Now, are we finished? Not ready, we still actually have a fraction. So, multiplying by the conjugate will help change secant x x minus 1 into secant square x minus 1 using the Pythagorean identity, we change it to tangent square x. So we're still working on to get it equal to cosecant x plus cotangent x. Alright, I'm going to erase to make more room. Alright, if we were to simplify, the next part we could do, just like in 5.1, is to convert all functions, all trig functions, in terms of sine and cosine. So, for secant, we're going to use the reciprocal identity. So, by using reciprocal, secant of x will change into 1 over cosine of x, and we have the plus 1. In the denominator, we're going to apply the quotient identity, which will become sine x over cosecant of x. Now this will become basically fraction with a term divided by another fraction. So basically 1 over cosecant of x plus 1 in parentheses, since I have multiple parts in the numerator, divided by sine x over cosine of x. So again, we're going to do, this is a division. Next, when we're having division of fractions, we can change it to multiplication. So the first part will stay the same. So 1 over cosine of x plus 1 and since we're changing the multiplication, we're going to flip the second fraction, so cosine of x over sine of x. So 1 over cosine of x plus 1 times cosine of x over sine of x. So what we're going to do, basically distribute cosine of x over sine of x to here, and then that to here. So when we're distributing, the first part, you're going to have 1 times cosine of x will be simply cosine of x on the top. Cosine of x times sine of x will be cosine of x, sine of x, plus 1 times cosine of x over sine of x will be cosine of x over sine of x. Next, I take a look and I notice in our first fraction we have a cosine of x on the numerator and a cosine of x on the denominator. In addition, cosine of x is multiplying to the sine of x, so we can simplify by dividing. So I'm going to divide by cosine of x, and I'm going to have left is 1 over sine of x plus cosine of x over sine of x. Now, even though they have the same denominator, I'm not going to combine it as one fraction. Again, the goal is trying to get it equal to cosecant of x plus cosine of x. So, if I take a closer look, we can do that. Here, 1 over sine of x, I can apply the reciprocal identity and then rewrite it as cosecant of x. Here, cosine of x over sine of x, I can apply the quotient identity, and that will become cotangent of x. So, the left side equals to cosecant of x plus cotangent of x, which is the same as the right side, cosecant of x plus cotangent of x. So, basically, we finished verifying, and I'm just going to write QED, saying that we're finished. So in review, by multiplying, we multiply the conjugate so that at the beginning, instead of secant x minus 1, we had it change after multiplying into secant square of x minus 1, then apply the Pythagorean identity, and then we keep simplifying where we end up with secant x plus 1 over tangent of x. And from 5.1, we rewrote it in terms of sine and cosine. Next, we wrote it as a division of fraction, then changed it to a multiplication of fraction, where we had this, and then analyzing it carefully, the first fraction we can simplify by dividing a common factor, which is cosine of x, and then after that, we apply the reciprocal identity in the first fraction, and the quotient identity in the second fraction, where we got cosecant of x plus cotangent of x. In our second example, we have cosine of x over cosecant x plus 1 equal to tangent of x times 1 minus sine of x. So, just like before, we're going to work with the left side. So, cosine of x over cosecant of x plus 1. Now, to help simplify the bottom, cosecant of x plus 1, we're going to multiply by the conjugate. So we're going to multiply the top by cosecant of x minus 1 and in the bottom. So on the top, cosine of x times cosecant of x minus 1, it will be cosine of x cosecant of x minus cosine of x. Then on the bottom, cosecant of x plus 1 times cosecant of x minus 1. That one you have to FOIL. And when you FOIL, you should have cosecant square of x minus 1. Alright. There's nothing I can do on the top, but we can simplify on the bottom. We can apply the Pythagorean identity. So again, the top will stay the same. Cosine of x cosecant of x minus cosine of x. Now again, cosecant of x minus cosecant square of x minus 1 is a Pythagorean identity that we can use. When you identify which Pythagorean identity and then you simplify where cosecant square x and the 1 are together, when you simplify, that will become cotangent square x. Alright. Now, what we're going to do is rewrite it in terms of sine and cosine. So, cosine of x times, we're going to apply the reciprocal identity on cosecant of x, which will become 1 over sine of x minus cosine of x all over. Now we're going to apply the quotient identity on cotangent square x, which will become cosine square x over sine square x. Now what we're going to do, since the numerator is being divided by a fraction, we're going to rewrite it as a division of fraction. So, since in the numerator we actually have multiple parts, 1 part, 2 part, so that's why I put parentheses. Now, at the same time, I'm going to multiply this cosine of x to 1 over sine of x. So, in the numerator, or in the first part, we're going to have cosine of x over sine of x minus cosine of x in parentheses divided by this. So cosine square x over sine square x. So again, I put this in parentheses because we had multiple parts in the numerator. Now, here, when I distribute the cosine of x or multiply to 1 over sine of x, the parenthesis on 1 over sine of x goes away, and we simply have cosine of x over sine of x. But we have the outer parenthesis still there. Next, I'm going to erase to make more room. Alright, so since we have a division of fraction, you can change it to a multiplication of fraction. So the first part will stay the same. Cosine of x over sine of x minus cosine of x, still in parentheses, times, we're going to flip the second fraction, so it's going to be sine square x over cosine square x. So what's going to happen here is we're going to distribute sine square x, cosine square x to the first fraction and then to the second part. So when we multiply sine square x, cosine square x to cosine x over sine x, it will be cosine x sine square x over sine x cosine square x, and then we're going to multiply this fraction, sine square x over cosine square x, to this minus cosine x. So when we multiply, again, it's like a whole number, we're just going to multiply to the numerator. So cosine x times sine square x over cosine square x. Now, what I'm going to do is, I see there's cosine on the numerator and the denominator on both fractions, so I'm going to rewrite it as, instead of cosine square x, it'd be 2 cosine x. So on this fraction, it'd be cosine x, same thing here, sine square x, instead of that, sine x over sine x cosine x cosine x. Cosine x, that was for the cosine square x. Now the next one, cosine x sine x sine x over cosine x cosine x. Alright, so next I'm going to divide the common factor. So I see that there's a sine x on the top and bottom, so 1 from both sides. I see there's a cosine x on the top and bottom, so 1 from both sides. Then I look at the other fraction, I see that there's only cosine x on the top and bottom, so 1 cosine x from top and bottom. So I am left with sine x over cosine x minus sine x over cosine x. Now this part, I can rewrite it, factor out the sine x, and then have one fraction left. So my first fraction still stay the same. So sine x over cosine x minus, so I'm going to factor out the sine x. When I do that, inside my parenthesis, what I have left will be sine x over cosine x. Now what I'm going to do next is I'm going to apply the quotient identity right here on the sine x over cosine x. Same thing here, so that we don't have fraction. The quotient identity for sine x over cosine x will be tangent x minus, we have the sine x outside, and inside will be tangent x. You can include the parentheses, but you don't have to. Alright, but we're still not finished, because you see how this is not alike to this one right here. So what I'm going to do, I'm going to factor out tangent x, because you see how there's tangent x on both parts. So when I factor out, it will be tangent x outside the parenthesis. Tangent x divided by tangent x will be 1. Negative sine x tangent x divided by tangent x will be minus sine x. And then close parenthesis. So now you see we verify and work on the left side, we had tangent x times 1 minus sine of x. It's the same thing as the original problem of the right side. So therefore, we finished verifying and matching both sides. So I'm going to write QED saying that we finished. So in review, we multiplied by the conjugate, applied the Pythagorean identity, we wrote it in terms of sine and cosine, then wrote it as division of fractions, changed it to multiplication of fraction, and then since we had sine square and cosine square of x, I wrote it twice so that it's easy for you to see that I divided one cosine on the top and bottom, one sine on the top and bottom on the first fraction, and then I divided one cosine on the top and one cosine on the bottom. So we have this left, factor out the sine x, and then I apply the quotient identity to get tangent x minus sine x tangent x, factor it out, and therefore the left side matches with the right side.